All right, let's look at some problems here. What two decisions can you make from performing a hypothesis test? Okay, what two decisions can you make? All right, so the decisions were based on what we do about the null hypothesis. So there were only two things that we could do. We could reject the null hypothesis or fail to reject the null hypothesis. That's all. Determine the statement shown to be true or false. If false, write it as a true statement. If you want to support the claim, write it as a null hypothesis. No, that's false. If the claim is the null hypothesis, you can only reject. So if you want to support the claim, you need it to be the alternative hypothesis. All right, let's say this is the claim, mu greater than or equal to 374. Then let's end up trying to build what the null and alternative hypotheses are. Well, again, mu greater than or equal to 374 is our claim. What's the rest of it? If it's not greater than or equal to, it's less than. All right, so now we decide where it goes. Well, the null has to have the equals in it. So mu greater than or equal to 374, which is our claim, and the alternative is mu less than 374. In this case, we have a sigma equals 6 as our claim. Well, if sigma is not equal to 6, well, that's indeed what the other part of it is. Sigma not equal to 6. All right, null and alternative. The null has to have the equals. That is sigma equal to 6, and in this case, this is our claim. The alternative, that's the rest. We already said that sigma not equal to 6. And on we go. All right, here the situation is given, the hypothesis test is given, and we want to know, is this a left-tailed, right-tailed, or two-tailed test? Where do we look? To determine what it is, we always look at the alternative. So the alternative is telling us sigma in this case, greater than 6.8. So let's say that's 6.8, that's over here, hence this is a right-tailed test. Let's say we had this situation. What type of test is it? Again, you always look at the alternative to decide what test it is. It's a p less than 0.2. There's 0.2, there's less than 0.2, that's left-tailed. All right, so we're going to write the claim, state the null and alternative, see which one represents the claim. All right. A laptop manufacturer claims the mean battery life for a certain battery, blah, 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 is more than 5 hours. So the mean is more than 5. All right, so that's the claim written as a mathematical statement. Again, that is the claim, but that does not have an equals in it, so it would have to be the alternative, meaning that the null would have to be mu less than or equal to 5 when the alternative is mu greater than 5. All right, so that's how it should have to look, and if I wanted to pick that out, and that one would be F here. It's easier to write it than to pick it out even. So that's a bit confusing. Which is the claim? Oh, well, the claim was back here, or in other words, right there. So the alternative hypothesis, mu greater than 5, is the claim. All right, next one. Same idea. According to a recent survey, 69% of college students use student loans to pay for college. Okay, that's telling me, it looks like they're giving a proportion. P equals 0.69. 69% of students use, so P equals 0.69. That's right there. Null and alternative. Well, P equals 0.69. That has the equals, so that's the null. The rest of it, P not equal to 0.69. And again, I'll just denote that this is the claim right here, so that I can easily answer the next part, which is the claim. Well, the null hypothesis being equal is the claim. Okay. This can be difficult, the type 1 and type 2 errors. Okay, so let's think about this. Okay, so what you have to remember is that a type 1 error is when you reject the null hypothesis even though it was true. And a type 2 error is when you fail to reject the null hypothesis when you should have because it was false. All right, so it's easiest to see what the null hypothesis is in order to make the decision here. So let's talk about what this is. So the store claims that at least 10% of its customers, so that's the proportion is 10%, so at least 10%, so greater than or equal to 0.10. That's the claim. It has the equals, so that's the null, and P less than 0.10 is the alternative. So again, if we're going to make a type 1 error, that means we rejected the null hypothesis when it was true. So it's true, the proportion of new customers returning was at least 10%, but we rejected it. So that's actually A here. The proportion to buy the new students is at least 0.10, but you rejected it. All right. The type 2 error, though, in this case, would mean I failed to reject it, but it was false. So, meaning that it was actually less than, the proportion was actually less than 10%, but I didn't reject the null hypothesis to get there. And that's down here. Actual proportion is less than 10%, but you failed to reject that. Let's try another one of those. Type 1 and type 2 error. So we really should always take a look at what our situation is via the hypothesis test. Percentage of adults have a job is greater than 88. So that'll be P greater than 0.88. Okay, that's got to be alternative because it does not have the equals. P less than or equal to 0.88. And this one is the claim here. Okay, so type 1 error. I would be rejecting the null hypothesis even though it's true. Okay, so I rejected the null hypothesis even though it is less than or equal to 88%. In other words, H0 was true. And here in this one, type 2 would be I failed to reject the null hypothesis even though it was false. So I failed to reject the null hypothesis when that statement that it's less than or equal to 88% is actually false. Okay, it's often a lot easier to state it than actually pick out an answer because it gets confusing, but that's all right.